Good evening, everyone, or good morning, good afternoon, depending on where you are. We will get started in about 3 minutes. Grab yourself some coffee or a drink, grab some food, and we will start the event in about 3 minutes. Okay, my computer just announced it's 7 p.m. over here, so let's get started. We're still waiting for Pauline to join. She mentioned she might be a little bit later than 7, but that's okay. We still have some housekeeping notes that we want to present. First of all, welcome to you all. It's amazing to see so much interest in this specific event. So I'm very excited to have you here. The agenda would be a welcome and an introduction, which will take roughly about 10 minutes, maybe a little bit longer just to fill up the time until Pauline joins us. And she will be talking about advanced Git magic. It was a blog post she had that sparked my interest, and I asked if she had a talk about it. She did had a complete workshop, which she reworked specifically for this event to be like a presentation. So I'm honored to have her doing this as a presentation tonight, and I'm very excited to see what she has to show us. Around 8 o'clock, depending on the duration of her talk and the questions, we will have a speaker change. You can have some time to get some drinks, have a walk outside, whatever you feel like. And then our second speaker would be Maaike Brinkhof. For people in the PHP community, she will be an unknown face, an unknown person. But if you follow also the testing community, she is well known in the testing community. And I invited her because it's testing madness this month. So I asked her if she could give us some insights for doing proper testing, and she presented this talk, The 3 Testing Terrors, which I'm very, very excited about. Let me put it that way. After her session, we also have closing notes and, of course, the raffle. And we will have a new gimmick, which will be an open discussion breakout session with Maaike Brinkhof. If you have questions about testing, about preventing terrors in your testing, and so on. I have no idea how it's going to work. It's completely new, but we'll give it a shot and we'll see where we end. So yeah, it's going to be a very exciting time. A little word about PHPBenelux. For those who are new to this event, basically we represent all the PHP communities in Belgium, Netherlands, and Luxembourg. And yes, they had monthly meetups, but because of the pandemic, those meetups yeah, stopped to exist, so to speak. So we decided that we take over and have like monthly meetups for everyone in the PHP community, especially in the Benelux area. But as we see now, also people from outside the Benelux are joining us. So welcome. I hope you have a good time, and maybe we'll see you at one of these local events again. Our speakers, Pauline Vos, will be talking about advanced Git magic, and Maaike Brinkhof. First of all, this is a very exciting time, and I have very much respect for the work that these women have done. So I'm very excited about having them here tonight at our event. Of course, this wouldn't be possible without the help of some sponsors. We thank Heroku for offering us socks and elephants, Spasi for supporting us financially, Intracto for supporting us financially, and Into-IT for sponsoring us financially and providing the logistics for the raffle prizes. Today's raffle prize will be sponsored by Intracto for the elephants. So if you are awaiting the raffle prizes, you have to sit throughout the whole session before we do the raffle. It will not be at the beginning. Of course, Heroku, you get a chance for the elephant, some socks, stickers, and a pack of cards. So. And of course, Into-IT, we do the shipping and delivery of all the prizes. And so let's see if Pauline has arrived. Yes, I see Pauline. I will make her presenter. So Pauline, oh, wrong button, make presenter.
Hello.
Welcome, Pauline.
Thank you.
I would say I let the introduction done by yourself. So
Okay.
who are you? And
yeah, I can just kick it off with the presentation if that's all right.
That's all right.
I'll just start sharing my screen. All right. Thank you. 1 second, and I'll share everything. Well, first of all, thank you very much for that lovely intro before. That was very nice words. And thank you for joining. This talk is Advanced Git Magic. It's the first time I'm giving this talk, so please give me any feedback that might be useful. If you think there's any way for me to make the content more clear for future audiences or make it more engaging, please don't hesitate to tell me. So a bit about me. I'm Pauline. I'm a software engineer from Amsterdam. I work at Werkspot, mostly back in PHP and a little bit of React as well. I'm a speaker and mostly about Git, so this is really my my topic that I'm passionate about. That there is my Twitter handle. It's Van Hamelbome. It's not my last name, I'm aware. It's an in-joke from years past. And I recently became June's mother. So this is June. She's 8 months old, and as you can see, she's very, very cute and cuddly. So like I said, this is the first time I'm giving this talk, and as such, I put forth a title, which I kind of now regret. I wish in retrospect, I would have called it Get Legit 2, Back to the Feature, because it's kind of a sequel to Get Legit, which is my original Git talk. And we're going to be doing a lot of time traveling. So advanced Git magic sounds kind of broad, but actually is quite specific. And it's really focused on time travel. So before we get started, let me just point you to this repo. Now, I always add QR codes, but this is a repo you can clone, so I don't know how helpful a QR code is going to be. But either way, my GitHub account is just my actual name. And then the repo is there, bisect regression testing. So you can follow along with what I'm doing kind of later on in the talk, and I'll tell you when. But I just already want to point you towards this repo so you have enough time to go and get it, and maybe you run Composer install and stuff. It does require PHP 7.4. I did start on a Docker setup, but I'm a bit of a Docker noob, so I'm afraid I didn't get to finish it. So if you don't have PHP 7.4 or up, then you're just out of luck, pal. But you can still follow all the pre-recorded demos and stuff and just try it again later. Okay, so like I said, this is kind of a sequel to Get Legit. So as such, it makes a few assumptions about what you know about Git. And one of those is that you are familiar with and may even already be using atomic commits. The other talk is mostly about atomic commits. And yeah, as this is kind of a sequel, it assumes that you are familiar with atomic commits and interactive rebase in order to keep your commits atomic. Ideally, you already use atomic commits, but if you don't, I can give you a little recap of the other talk, a little summary. So atomic commits are just normal commits, but they have a few features. So it's just a different way of organizing your commits, basically. So an atomic commit will be a single irreducible unit. So just like an atom, you can't split it without things exploding, right? The same goes for atomic commits. You can't split it without breaking stuff. They're that small. They're as small as possible. And they only pertain to one fix or feature or whatever you're doing. So you're not trying to solve a million different problems in one commit, basically. And second, everything works. So don't break the build on any commit. Make sure it's covered. Make sure the tests are agreeing on every commit, not just at the end of your PR. On every commit, you want the application state to be captured in a stable state on every commit. Then number 3 is they have to be clear and concise. So the purpose is clear from the commit message and the description. And as you can imagine, with time traveling going back and forth in your history, that becomes kind of important. And one other thing that is going to be especially important for the things that we're going to do in this talk, as those things are not really going to be possible without this part, is that everything works. So you don't break the build on any of the commits. You'll see why later. But yeah, just for now, that one is very important for what we're going to do. So that's what makes an atomic commit. And to organize commits, you need to be able to interactively rebase, because you need to be able to add changes, reword things and stuff to really keep those emits really small and organized and atomic. So an interactive rebase is just like a normal rebase, but interactive. So you do that with an interactive flag, so --interactive, or just this -i. And yeah, like I said, it's just like a normal rebase, but as it's interactive, you're given a bit more control over how the commits are replayed. So with a normal rebase, you're going over commits one by one. So you're replaying commits one by one. And with interactive rebase, you have control over how you replay those things. So when you enter interactive rebase, it'll open a little swap file that looks like this. And at the top, you'll see the commits that it's going to go over and replay. And they're prefixed with pick. Now, if you keep that pick there, it's just going to replay as normal. Like with the normal rebase, it's not going to do anything. But you can also replace the pick with one of the things in the command legend down there. So you can reword the commit message. You can edit the commit. So add changes, remove changes, reset it. You can squash one commit into another to make one commit out of two. You can even run commands on commits like your lint or your test, whatever you want. And so in that way, you can kind of create rewrite history if you do this over your own branch. Also, if you do it over other branches. But to keep your commits atomic and to rewrite history like that, you're going to interactively rebase onto your own branch. And this is how you do that. So you just interactive rebase and then head tilde 4. So the 4 is how many commits you want to go back from your head. And your head is the point at which you're now, the point in time that you're now at. So let's see that in action really quick before we move on. I've got some unstaged changes that I'm stashing. I'm going to enter interactive rebase. And I can replace pick with edit. And when I write that file, it will check out both of those commits that I've said I wanted to edit, and it will replay the other ones as normal. So now this is the first commit. I'm staging these changes. I'm continuing. I can change the commit message if I want as well. So this is how I'm rewriting that commit, rewriting history. And I'll do the other one, make some changes here as well. So same exact thing, stage. Well, you get the point, right? So it will continue to rebase until eventually you're back at your head, and then you've rewritten history. So that's as far as we'll go with the recap for now. So let's move on to some kind of SQL material, not the database query, the SQL of Get Legit. So we'll kick it off with some light time travel. So you want to kind of be able to travel back and forth in your history in your own branch, right? So you can do that by checking out certain commits. Like here, you'll check out, just as you're checking out a branch, you're checking out a moment in time. And in this case, it's head tilde 5. So you're counting backwards 5 commits from where you're at now, and that's the commit that you're going to check out, as if that is your head. And you can follow along in your own terminal if you want. So you can kind of see what's happening. So just any repo, not even the one that that I gave you before, just any repo, just try it out, git checkout head tilde 5, make some changes and commit them. Then go back to your head by going git checkout dash, which just takes you back to the place you were just at. And then go git log, and you'll notice that your commit is not there. Now that is because you're in a detached head state, and that is kind of a mystical state that a lot of people get confused by. It's kind of like a virtual state. So you've probably noticed this. If you've ever done this, you've noticed this, this text, and it says you're in a detached head state. You can look around, make experimental changes and commit them, blah, 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 blah. But if you actually want to retain that, because the changes that you're making in this state are only experimental, you have to check out a fresh branch, because this experimental virtual state kind of ensures that you don't accidentally overwrite stuff that you don't want to explicitly overwrite. So when you're rebasing, when you're interactively rebasing, you're really explicitly going in there and saying, I want to edit this commit, I want to rewrite. So in this detached head state, you're prevented from doing that because it's an experimental state. And if you really, really, really want to keep your changes, you can do that, but then you have to check out a new branch. So let's try that again. This time we're going to check out a commit by its ID. You can also do that by reference. So you don't have to count back like we did before. You can just take any specific ID, and you'll notice that it will say detached head state. Now try to make some changes again and commit them, but this time check out a fresh branch. And now when you git log it, you'll notice that it's there. And then what you can do is you can either go back to your original branch and cherry pick that commit, or you can go back to your original branch and reset it to your new branch completely. And then you'll have the state of that new branch. But then you're doing it very purposefully, so not accidentally. So it's a bit different. Okay. So a lot of people, when they rebase and when they start interactively rebasing, will have the experience that at some point they've screwed something up. And, as you're rewriting history, that feels a little bit scary, right? Because you're overwriting the commits that you had before. So if you're accidentally removing stuff or overwriting loads of stuff, it can be a bit scary. But luckily, there is a way to time travel that isn't this. You can time travel not just through your own log of commits, your actual log of commits, but also through ref log. So the difference between your normal log and ref log is that the normal log is permanent, and it's really just the history of commits. And your ref log is not permanent. It has a set amount of references it keeps. And it's really just to keep track of all the individual steps that you've taken, all of them. So that includes checking out branches, checking out commits, rebasing, what else? Well, just basically everything that you're doing. So not by commit, but really by action that you take in Git. And just as we were checking out specific commits by their ID just now, you can do that with references in your ref log as well. So let's say you accidentally dropped a whole commit that you didn't want to drop in your interactive rebase. All you have to do is find the reference from before you started that rebase and check that out and create a fresh branch from it. So I'll show you that in a second, but you'll see here, I'm just going to take you back to the ref log. That first line, for instance, you'll see that's in the description there. It says rebase-I start, right? So that is, that is where you started your interactive rebase. So if you want to undo that rebase, you want to go to the point before you started that rebase. So that's second line. Okay. So if you want to do that, just check it out. I promise you this is safe, so you can do it to any repo that you want if you want to follow along right now. So just go into your interactive rebase, then drop any commit. You do that by in Vim by going dd. That just cuts the line right out. And if you write that file and finish the rebase, it'll take you back to your head. And if you say, oh no, I didn't want to delete that whole commit, you can go into your Git ref log and you find the bit where it says rebase-I start. And then the line after that is the one that you want, because that's before you started rebasing. So you're going to check that out just as we were checking out a commit before, not this reference, because your reference is going to be different, of course. But just git checkout and then that reference, and then it will take you into that detached head state again. So if you want to keep the state from that reference, so you want to keep the state of your branch before you started your rebase, you check out a fresh branch like before. Then you go back to your original branch and you reset it to your new branch. And that's how your original branch is exactly the same as it was before you started your rebase, and you've undone your screwed up rebase. So you've rewritten history. So that's how you fix a screwed up rebase. Now, next, a little bit of a recap again, because this is the thing that is going to get really interesting. IMO. I always get really excited when I can talk about this this topic. So in the original Git Legit, I touched upon bisect, and in this talk we're going to go deeper into it. So I always, so this is a recap part. So sorry if you've already seen this. But I always explain the concept of bisect using some eggs and a building. So let's say someone asks you to find the first story of a building that you can drop an egg from without it breaking. So you start at the bottom level, so it's ground level. You drop the egg, it doesn't break. Next one, drop the egg, doesn't break. And you keep going until finally it breaks. Now, as you can imagine, if you have a very sturdy egg and a very tall building, this can take you many, many, many iterations. It might take you 40 floors before you get to the first floor that breaks the egg. So there's a different method you can use to search for that floor, and that's called binary search. And that is what bisect uses. There's a few other more mathematical terms for it as well. Yeah, so instead of going floor by floor by floor, you start in the middle of the building. You notice that it does break. So you know that the first floor it will break is between there and the ground floor. So then you go into the middle of that. It doesn't break. So then you know the first floor that it does break is between there and the other one. And you keep going in the middle until you've narrowed it down to just one. So that is the same approach that bisect takes to your commits. So if you're trying to find a point in time, and it can be like to find, well, not changes, well, yeah, I guess. It can be certain changes. It can be when your application was broken or whatever, when unexpected behavior was introduced. You can find that really easily by bisect, where normally you might go commits by commit by commit, just checking all those commits out until you finally find it. You just take a beginning point where you know your application was working, for instance, and your endpoint, which is head, because that's where you're at now. And then bisect will just search for the middle, check that commit out, ask you if it's good or bad, and just keep doing that until it finds the first commit that was bad. So this is what it looks like in action, and then we're going to go deeper into it. So you start your bisect, and you give it a good commit to start with by commit ID. So where your application was working. Then you're marking your head as bad, and then it checks out the commit in the middle. You check it, you mark it as either good or bad, and after a few iterations, it will give you the first commit that was bad. So whatever commit was introducing a bug or whatever. So you might be wondering, instead of marking everything good or bad manually, can you automate this? And the answer is yes. You can give bisect any script that you like that exits with an exit code for 0 for success or anything else for failure. And instead of marking it manually, bisect will run your script on every commit that it checks out and will automatically mark it good or bad for you based on that exit code. And this is what some people on MTV Cribs might say, where the magic happens. So let's say you have a situation where all of a sudden you've noticed that there is a file missing that shouldn't be missing. Normally, when there's unexpected changes, you could go into your ID and you could see who changed what and when and what the commit message was and all of that stuff. But if there's no file to annotate, it becomes kind of difficult, right? So what you can do instead is, outside of your repo, you can create a little script like this that just checks for the existence of a file with a given path. And as you can see here, it'll echo yep if it finds it and exit 0 for success. And otherwise, it'll exit with nope, which is not 0. So that's a failure. So let's see what that looks like in action. So you'll see this directory contains, in the top left, it contains a directory called calculator, but underneath that calculator directory should be a calculator.php file, which is not there now. So in order to find out when that file was deleted, I can start my bisect, just like before, and give it a point in time where the file did exist. and then mark my head as bad because the file doesn't exist. And then instead of marking good or bad, I can go git bisect run and give it the command to run my script. And then it'll start doing those iterations. It'll check out every commit and run my script, and you'll say it says, yep, nope, nope, yep, until finally it finds the commit that's deleted the file. Okay, so can you think of some other scripts that might work much the same way with these exit codes? That's right, tests. So a test will succeed if it's with an exit code of 0, and it'll fail with something else, either an error message or -1 or whatever. So tests work the same way. So if you don't have an amazing CI/CD pipeline, which a lot of people don't, and you don't have a hard requirement for all your tests to be green before you merge anything into main, you might end up with, on your main branch, with a lot of tests that have been broken for God knows how long. And you might at some point want to figure out, hey, when did a certain test break? So you can do the exact same as we've just done, except with a test. So let's see how that works. So the exact same thing again. Let's call it the power of repetition. Git bisect start, git bisect bad for the head, doing it the other way around now, and then git bisect good is a commit where the test used to pass. And then I'm going to give it the test, and it'll check out the commit in the middle, run your test, etc., and mark it good or bad if it succeeds or fails. And then it will give you the commit that broke your test. So the first bad commit is the one that broke your test. And then you can look at your commit message, you can check out that commit, see what happened, etc. Okay, so now that we've done that, can you imagine why this is very important for this auto-bisect stuff? Exit codes. So like I just said, like I explained, the auto-bisect will automatically mark commits as good or bad based on the exit code, right? But if you, for instance, misconfigured something, or there's a service that doesn't exist or whatever, and you're running your test and the application doesn't run properly, then something else might cause this failure. So bisect is going to be marking commits bad when it's not your test that's failing, it's your application that's failing. So you can't really do this if not everything is stable, is captured in a stable state on every commit, okay? Because then your bisect doesn't point you to the point that you actually were telling it to find. And that, as someone on MTV Cribs might say, is where no magic happens. So make sure that your application state is captured in a stable state on every commit, and then you can make use of all this bisect magic. So, question. We were just looking at a test that had been broken for a while, right? So it was covering some behavior, but the test had just been broken for a while. Now, who of you have an amazing CI/CD pipeline and do have a hard requirement of all the tests being green and still end up with bugs in production sometimes? I think we all have that because, sometimes maybe your test isn't covering what you think it's covering. Maybe there is a test case that you missed and there's some uncovered behavior. So sometimes there's unexpected behavior in production that was never covered in a test. So what is your process when that happens? So for a lot of people, it would probably be something like this. You find the bug, or someone tells you about the bug, and then you go screw around in the code. You might even take a look at the commit log and try to kind of guess which commit was the perpetrator. And surprise, surprise, it's never that commit that you think it is from the description. Then finally, after painstakingly trying to find it for ages, you'll find the thing that broke the stuff, and then you'll fix the stuff. And if you're a good little developer, you'll create a regression test to make sure that it doesn't happen again. If you're feeling fancy, you might even start with that regression test. And then it fails at first, but then you fix stuff until it doesn't fail. And then you have your regression test and you fix. Great. But what if I told you that you can find out about the bug, create the regression test, and then fix it immediately? Because you don't have to do any finding. The test does it for you. The test finds the problem for you. So this is where I would like to ask you to follow along with the repo I was giving you before. And if not, it's totally fine. You don't have to follow along in the repo, but it's just fun. So if you do have the repo, check out a branch called Trogdor and maybe look at the code a little bit. I'll just quickly show you the code as well. So this is our run script. It instantiates an app and it runs it. And the app, you'll see, creates a village in Trogdor, who is our dragon, and Trogdor likes to burninate stuff. So he likes to burninate villages, and that's all the app does. So if we go back to the presentation real quick, 1 second. After you run compose and install, try to, and make sure you're on the right branch, by the way, Trogdor. Run php app/run.php. If you don't have it, this is what it looks like when you run it. So let's look at our log. You'll see the last commit is let it burn, which introduces the script. We're now going to run that script. And you'll see there's some output there, some output text saying commencing burnination. And then for each cottage in the village, it'll say it's burning. And then when all the cottages have finished burning, burnination is completed. Okay, so
interrupt you for a second. Can you make the screen size of this a little bit bigger? Command plus.
Well, this is a pre-recorded video.
Oh, okay.
All so right. I'm not sure. Is it really bad to read?
It depends. I have a very small screen, so for me it's tiny, but maybe on the video it will be okay. Never mind. Continue.
Okay, so if you see anyone saying in the chat that they really can't read it, maybe I can just go into terminal and command plus it.
The reactions is that everyone is capable of reading it. It's just me.
Okay. Okay, good, because I really don't like live typing at all. I always make typos and stuff. Okay, so thanks, by the way. So this is what happens when you run the script. You see the output. But over time, more commits are added, right? Changes are made, blah, blah, blah. Of course, we don't have that real time here because we're doing a fake thing. So I've just made another branch for you that pretends it's this branch, but in the future. So if you would kindly check out Trogdor-test if you're following along, then I'll fake do the same in my pre-recorded demo. So check out Trogdor-test. And then if you look at the history, you'll see that since our last commit, that's on our main branch there, the let it burn one, there's been some new commits. But now if we run our command again, you'll notice there's no output. So Trogdor is not successful in his burnination. And we haven't covered any of this, of course. So what we can do now with this unexpected behavior is we can write a test for it first and commit it. So I don't expect you to write this test right now if you're following along. That's why it's already been committed on that branch. But like this test, it could just be a simple test here expecting some output text. So this one checks for burnination completed, and then you can commit that test. But of course, when you commit it, it's going to fail. You can do that on that branch right now. You can run that test, and it's going to fail because our script doesn't work. Now what we can do is go into our interactive rebase, go back 14 commits, and we cut the line for our test commit and put it in the moment in time where we knew it was still running fine. So that's by the let it burn commit. Okay, so we've now pretended that the test was there all along. See, there it is. And then we can just double check that it actually succeeds there. You don't have to do this, but just for me to prove to you that it does actually run. And then we can do the same thing that we did before. We can just start bisect and give it that one commit where it doesn't fail and mark our head as bad. And then instead of marking everything manually and running the script, we can just run the test. Let's bisect auto run the test on every commit. So it will do all those iterations. And then it will give you the first commit that's, well, the commit that introduced the unexpected behavior. And that is the commit, or maybe he was just a dragon. Okay, so now next step is to see what actually happened in that commit. Luckily, your commits are atomic, so they should be pretty small. So let's see what actually happened there. Got our commits here, and that was the commit that introduced the unexpected behavior. So we wanted to see what the difference was between that one and this one, the one before it. So git diff, commit before it, and the commit that introduced the bug. And -w just gives you a bit more context around the changes when you diff it. So you'll see here that instead of a dragon man, Chogdor is now just Chogdor, the dragon. So this conditional that's checking for dragon man is causing the bug. It's causing him not to burninate. So we can check out, that was a little copy paste boo-boo there. We can check out the commit that introduced those changes. And we can just open the app class and fix that behavior so that our test does succeed. So we're going to change this as dragon man condition to as dragon. And then we want to make sure that Chogdor also has an is dragon method. So we can go into our Chogdor class. And we can just change that is dragon man to is dragon. Save that. Okay, and then we run our test again to make sure that it's actually not failing now. Okay, so we fixed the bug. Now we can commit the fix. So we create a commit, crappy commit name. You'll see why later. And then we check out a fresh branch. Why? Because we time traveled like before. We traveled to a specific commit on our branch. So we're in that virtual detached head state, remember? So we have to check out a fresh branch in order to keep the commit that we made in this experimental state. So that's what we're going to do. We're going to check out a fresh branch. And then what we can do on that fresh branch is confirm that the test is still there and the fixed commit is also there. And then to make a nice atomic commit so that you can create your PR, we can go into our interactive rebase, take that test commit, and just smush it together with the fix with squash. And then we can give it a nice commit message as per feature number 3 of atomic commits. And there you have it. Then you have a nice atomic commit that fixes a bug, creates the regression test, so it won't happen again. And it's all gone a lot faster than you having to dig around because the test has done it for you. So now you can create your PR and everyone's happy. See, so now you have that one commit and you can either create a PR from your new branch that you have here or go back to your original branch and cherry pick the fix commit or reset it to this fresh branch. So there you have it. This is how you can really easily find the unexpected behavior, what caused it, fix it, and cover it in one go instead of this whole big process. So I hope that was clear to you, and I hope it was useful to you. If you have any questions, please do let me know, and I'll try my best to answer them. And also, remember feedback. First time giving this talk. Thanks a lot.
Yeah, I'm speechless, Pauline. That was
I hope that's in a good way.
yeah. I've been following along, and I checked out the repository. Was doing the same thing. It was very fast for me to keep up, but wow, no, amazing.
Yeah, maybe it's a bit of a workshop format, but I figured, well, while we're all at our computers, maybe we can all try it.
Let us know where people can get that workshop, because I think you just sold it to everyone here.
Yay! That's nice. I'm excited that everyone's so excited about it, because I always get jittery talking about auto-bisect.
Yeah, well, it is amazing, and especially seeing it happening. Yeah, I'm speechless. Yeah, wonderful. I was looking at the chat. I see nothing but claps and brilliant, good stuff. Just one person who said, let me just start
Let's
the Q&A.
burn enums, I think I saw.
Yeah.
That's fair enough.
Let me put it here. So the mentioning was QA modes. So how can people get more Git confidence?
Right. Okay. So, hi, Mark. Yeah. So, thanks for the remark. I suppose more than a question. Did you catch the reflog bit? Because you might want to take a look at that, because you can literally undo any mistake that you make. Really, even if you're too scared to even use reflog, just always make a fresh copy of your branch, and it's fine. You can screw around on that and go back to your original branch whenever you want. But if you really want to do it on your own branch, you can always just undo anything that you do with reflog. So I do think if the recording comes out, maybe take a look at the reflog bit again, because it's super nice if you're not confident with rebasing yet.
Yeah, people were asking about the video. We're also doing a live broadcast on YouTube. So the moment that we say the event has ended, we stop the recording, and the video will be available at the same link that we announced. I will publish it later on as well. The second question: how do you deal with having to fix up the same merge conflict like 10 times when rebasing?
Right. Okay. So this is actually that bit is actually covered in Git Legit, and I totally forgot. I was gonna put the links to my Git Legit cheat sheets and the summary blog post of it in the presentation. I totally forgot about that. Maybe I can put it in the chat. But yeah, that is actually covered in the other one. That talks about atomic commits. So this problem with the same merge conflict constantly doesn't actually happen when you use atomic commit. So the thing about rebasing is that, and I did the same when I first heard about rebasing, because people often kind of evangelize it without really properly explaining what it does and why it's good. And so people end up just using rebase without realizing that you can't really, there's no point really using rebase if you're not using atomic commits. Why? Because, like you say, Gert, you're going to end up fixing the same merge conflict 10 times. That is because you're not committing based on units, like when you are with atomic commits and cleaning up those commits. You're committing chronologically, like a save point in a game, or like a Word document or something. You're committing because you did some code, and then you do some other code, and then you do some other code. So the way rebasing works is it replays every commit and checks the delta and sees if there's a conflict between that commit and the other one. So if you are chronologically committing, you're going to be replaying the same part of the code. That's why merging is easier if you don't do atomic commits, because you just take one head and smoosh it together with the other head, fix merge conflicts, fine. But with rebasing, you're going over time, right? You replay every commit. And so you're going to run into the same exact part of the code time and time and time and time again. So there is a way around it, by the way. You can use a ray option, which will just automatically remember how you've solved the previous conflict and just apply it again. But yeah, that kind of forgoes. I don't recommend that because that kind of forgoes the whole point of, you probably shouldn't be using rebase without having atomic commits. So that was a really, really long answer. Sorry about that. But yeah, I think, is there a link? No. Oh, join in. Okay. I'll post the link to the cheat sheets in the chat real quick.
Yeah. And we will send out a message to all participants after the event as well. So if you have links that you want to put in there, I will also put the link to your repository in there so people can play. Maybe something you want to be aware of, Chris Harches is really, really excited to see how you do this. So you got his attention as well. So.
That's nice.
Yeah. So yeah, congratulations. Yeah, I don't see any other questions. Oh yeah, just one in.
Yeah.
Let's publish it. Is there a place where we can do code katas for atomic commits and other Git actions?
Yeah, I do have some on my GitHub, but it kind of it doesn't really have very good instructions because so far I've only really used it in workshop days. So it might be to put some work into actually making that a bit more, well, a lot more, so that you can actually use it as a code kata. Because right now it's basically only possible if I tell you what to do. And other than that, I'm not sure if there are any. I don't know any. I'm sure there are, but I don't know of any. Oh, I do know. Sorry. If I can just add to one thing, I do know that Atlassian has really amazing documentation on Git, way better than the actual Git documentation. So that's definitely another place to look.
Okay. Well, that's all I see for questions. So yeah, people are happy. People are excited. Like I said, I'm totally blown away. Thank you very much. We asked you to do this on a very short notice, and yeah, this was beyond our expectations. So thank you very much.
Oh, that's lovely. Thank you so much. I'm really happy it worked out.
Yeah.
Okay. Thank you.
Okay.
Should
I'm going to take over now, and
okay.
I will make you attendee, and make you attendee first. There you go. Yeah, I'm back to my presentation. So the advanced Git magic was awesome. We do have a break in the middle. It's now 10 minutes before the hour, or 8 minutes before the hour. Let's make this 10 past the hour. Let's see if I can edit this. And now I need to resize it. Where's my pointer? There you go. Bam. So let's get back here at 10 past the hour. And yeah, we'll see you after the break.
You.
Hello.
Hello.
Yeah, we're just having a break. So if you want to see if the setup works just like yesterday, feel free to...
Mag Nederlands nu, hè? Nog even, of niet?
Ja, Nederlands. Ik denk dat de meeste wel Nederlands zijn. Maar we hebben ook andere mensen en ze kunnen het toch wel een klein beetje volgen. Dus,
Oh, ze kunnen mij nu al zien.
ja.
Oh no.
Ja, maar dat is het leuke aan de meetup. We kunnen hier een beetje...
Ah, we can already have a chat, you mean?
Yeah.
All right.
It's all informal. Let me put it that way.
Oh, this is the worst moment in time. The moment where you're waiting to start your talk, but you can't start. You have to wait.
Yeah, maybe get a drink, get some fresh air, clear your mind.
Already done that.
Oh, okay.
I'm still. Oh yeah, no, we have a curfew in the Netherlands, but that starts at 9 p.m. So I could still go outside theoretically.
Mm-hmm. I will do the same thing. I will go outside for some fresh air, and I will be back in like 5 minutes.
Okay, see you then.
All right. Bye-bye. Okay. If you're having issues with the sounds, let me see if I can correct it. There we go. Okay. Yeah. Just came in. It's a bad day for data centers this week. First, we had a destruction of OVH data center in Strasbourg, and now just in Tokyo, AWS building is burning down. So yeah, it's a bad day if you're having a data center. So make sure that your data center is not on fire at this point, and hopefully things will get better. So if you're doing some cloud work in Asia, you might want to check your performance at that point. Yeah, Terraform apply. Yeah, that was the disaster recovery Terraform, I assume, Tom. Yeah. Yeah, we had Pauline talking about dragons and burning stuff down. I can say it wasn't me. I was just outside for 5 minutes. That's not enough time to fly to Tokyo and back. Also with the restrictions due to COVID, I'm not able to leave the country. So anyway, it's almost 10 past the hour. Maaike,
Hi.
you ready for your session?
Yeah, let's see if this screen sharing thing works. Okay. I'm clicking on open in browser and nothing happens.
Ooh.
We tested it yesterday. I'm not kidding. The button doesn't do anything.
Let me double check here. Maaike.
Well, I clicked on it once before and then I dismissed it, so I know it's not a permission thing.
Okay.
It might be a genuine bug.
Could be.
Shall I do a good, have you tried turning it off and on again and rejoin?
Exactly, that's exactly what I was implying. I will make you attendee and make you presenter then.
Yep.
If that works.
Yep.
You should be able to. Did I now lock the camera interfaces and lock mic? Lock mic? So confusing. Maaike, are you able to start video and audio? Nothing works. Okay. This happens all the time. You test it once, it works. You test it twice, it fails. Where is the mic? There you go. Make presenter. Unlock mic. Unlock camera. And enable screen share.
Hi. This is hilarious.
The magic of the IT crowd, right?
Well, I do have a theory about why this bug occurs, because when you gave me presenter rights the first time, I started the screen sharing and then I canceled it. And then the next time the button didn't respond anymore, which to me is like, oh, this is a state thingy or something. But I don't know. I don't know their code.
Well, it's registry, so we should be able to assist them in making it better.
Okay. Do you see something now? Do you see the presentation now?
Yes.
Hallelujah.
It works.
Okay.
Maaike, take it away. I will mute myself until there's something that pops up, and then I will just whisper in your ear. Okay?
Yeah, because right now my keynote is full screen on both my screens, so I'm effectively blind. And it's like speaking into a void, which is really interesting. But anyway, let's get started. Hi, people I don't know and can't see. My name is Maaike. I'm from Utrecht, the Netherlands. I don't know anything about PHP, but it doesn't matter. I'm here to talk to you about the 3 testing terrors. And I'm pretty sure there are more than 3 testing terrors, but this title just iterated extremely well. And I'm sure you want to go to bed at some point this fine evening. I've been a tester for the last decade. I know jack shit about PHP, but I do know more about the mobile world. I've been a mobile tester for most of the past 10 years, so that's more of my expertise. Anyway, let's get started with a nice bug that maybe some of you remember, at least the Mac OS users might remember. We have to go back to the end of 2017 for this one. And Apple released a new version of what was back then the latest Mac OS version, High Sierra, and it had a terrible bug. You could log in as root if you just let the user field empty and pressed enter a couple of times. This was known as the I am root bug. And what's interesting about this is that so many reactions online, because many people did react, but many of those people blamed testing. And I see this happen a lot because, let's face it, bugs are everywhere and almost anyone deals with them in production. It just happens. But still, people expect that testing is like a catch-all magic wand that you wave and then it will save you from everything and prevent all the bugs. And makes me feel like this. So in the next half hour or so, I would like to explain to you 3 common misconceptions about testing. But before we get to the actual terrors, we have to back the truck up a little and go to the boring basics. I'm sorry. But we have to talk a little about what testing is, because I want to try to avoid at least a little bit of the shallow understanding. And plenty of people think plenty of different things about what testing is. So this is my point of view. This is my opinion, if you will. So keep that in mind. So if we take an extremely simple definition of testing, then you can say that testing is checking whether expected result X is truly X. This is what you see in practice a lot, that people think this is testing, especially developers sometimes, because if you believe this is all that testing is, then everything has a Boolean outcome, right? It's about confirming ideas. And it's nice because if everything is a Boolean outcome, the world is nice and simple, black and white. But as you can tell from the way I'm talking about this, this is not what I believe testing is. I prefer to go more the scientific route. And I see testing as performing experiments and then interpreting the results. I think that this definition promotes skepticism, critical thinking, and most importantly, open-ended thinking. Because just like coding, testing is a cognitive activity. The brain is at the center of it. And software testing experiments don't have to happen on code. You don't have to interact with the software to say that you are testing. If you're asking the right questions during a refinement, you're testing. If you're trying to find out if an idea has merit before you even write a line of code, that's testing. So this is the definition I'm way more comfortable with because of its open-endedness. Testing is not just Boolean, it's about exploration, experimentation. So that's one part of the puzzle, but there's another part missing right now. And now we know what testing is, but it also has to have a goal, which is very important. And here's where it gets a little bit fuzzy. But I think with testing, we're trying to gather useful information about the product while we have constraints. And the constraints are plenty. They're time, money, means, people, knowledge, and so on. But you see the problem here. That is the word useful. Because it's a value-based word. Like, what is useful? You can't really measure it. There's no KPI to think of this. And this is what makes some people uncomfortable. But what I think is useful, I apply risk-based thinking. I know that I cannot gather all the useful information there is out there. There's simply too much of it. But given that I have constraints in time, that's most likely the biggest constraint we all have, then I will choose to do my testing in a risk-based manner. And this is completely context dependent. What is your biggest risk? So I cannot give you the answer what it is for you, but I'm sure you know. I'm sure you know in your context what part of your product often has problems. Well, then you know you have a risk there. So that is the missing link. But let's say that I have found tons of useful information. At least I believe it is useful because it's a value thing. Then there's another problem. Information is only useful when people act upon it. This is what makes the position as a tester difficult at times. Because believe me, I have found issues, and I think they were terrible issues, but they were then swept aside by management or the product owner as not important, or, oh no, we don't have time for that. The things I find useful can easily be dismissed by others because they don't find it useful or they have other goals. Company politics sometimes don't help in this regard. So yeah, there you have a very small introduction of what I think is testing. It's open-ended. We're trying to find useful information, but we have to deal with the fact that this usefulness is very subjective, and sometimes people can toss information aside because we don't agree on its usefulness or because of company politics. So knowing that, we can move on to the 3 terrors, because what are they even? Well, the first one is testing can be fully automated. The second one is testing can have complete coverage, and we'll end with testing equals quality assurance. So let's go to the first one. Testing can be fully automated, or a slightly less horrible version, should be automated as much as we can. As long as I've been in the testing world, automated testing has always been accompanied by these big, big promises. Yeah, it's repeatable, it's comprehensive, reusable, it leads to better quality supposedly, and what managers like the most, it reduces costs. Basically, it's sold as a silver bullet, as if this is all you need to do testing. But what you often see in reality is that test automation can look a bit like this, like you're trying to stuff it into holes it doesn't really fit into. It's Or what about this one? Like, yeah, you write unit test, yeah, the shit is working fine, and then it's like, too bad, didn't work. Or yay, my unit tests work, and oh, together it all goes to shit. We've all seen it probably. So what is the solution? Just add more integration tests to find it out? Do more manual testing? The people in the testing community have tried to solve this problem by giving this heuristic, the test automation period, where supposedly you have to write mostly unit tests, fewer integration tests, and then on top you have a few UI tests, because apparently a unit test is cheaper than a UI test. This is information that is thrown around like it's an absolute truth, but I don't know, man. And then on top of the pyramid, you have this little cloud that is manual testing. But is this true? In reality, it's often like this. What people don't realize is that we cannot automate the creating of our test automation. So saying that testing can be completely automated doesn't make sense. The thinking, the manual testing, I hate the term manual testing, by the way, but thinking is always at the base of it, and you cannot automate thinking. And if you just look at the terminology here, like we don't call programming automation or automated programming, it doesn't make sense. We also don't call it manual programming. That's just ridiculous, right? Automation in testing does have its place. I'm not saying that you don't have to automate anything, but it's like certain tasks in testing can be automated and should be automated, but you cannot automate testing as a whole. I'll explain why. If you believe that you can automate all your tests, you have a problem. Remember that we're looking for useful information. If you believe in test automating all the things, then you're fully in the known domain. Because in order to write a test, you need to have an expected result. So you can check for that. But then what's your problem is that you're missing a lot of potential information. Because in the real world, you can't test everything because you can't think of all the test cases. No one can. So you have the area of the known unknowns and the black swan area, the unknown area. So how can you go into this area? Well, to me, the answer is clear with exploratory testing. So you exploratory test to find out more information. You explicitly go into the domain of the unknown, and then you uncover information. Maybe you find a couple of bugs. And then what happens is the information you found moves back to the known domain. And then nothing stops you from writing a test for it, right? So this is more of a complete picture. So instead of thinking that testing can be completely automated, think of it like this. Test automation and exploratory testing go hand in hand. They complement each other. You have to go into the unknown. And sadly, an explanation about how to do exploratory testing is beyond the scope of this talk. But I want you to remember one thing if you didn't know it already. because exploratory testing is a systematic approach. We're trying to discover risks and we're using analysis techniques and a lot of testing heuristics. But I made the two words I want you to remember annoyingly green. It is a systematic approach. I've come across developers who think that, oh yeah, I'm opening the app and I'm just doing some stuff. That's exploratory testing, right? No, it's not. Then you're doing stuff at random and it's more like monkey testing. You have to have a system behind it. Even though I can't give you a proper explanation right now, at the end of the talk, I will give you a book tip if you want to learn more about exploratory testing. But we can wrap up this terror by remembering testing is test automation plus exploratory testing. Bring more variety in your testing. Terror number 2. Testing can have complete coverage. And this goes beyond the 100% test automation, although the two are a bit linked. So let's look at a nice little code example. So let's say you want to go for 100% code coverage. And you have this function and you have to write tests for it. Every time I hear developers or other people talk about coverage, and I'm like, do you even know what it means? Because what type of coverage do you mean? Do you mean function coverage? Do you mean line coverage? Do you mean statement coverage? Condition coverage? Branch coverage? Parameter value coverage? Entry-exit coverage? Loop coverage? State coverage? What do you mean? Often nobody specifies what kind of coverage they mean. They're just going for the number, the 100%. And realize, even if you have perfect coverage, you also need the perfect assertions to go with them, because 100% code coverage says nothing if you have unexpected return values or side effects. And even with a tiny function like this one, without side effects, the possible scenarios explode. So how can you say 100% coverage? And we're not even talking about 2 or more functions working together here, because that would exponentially increase the number of scenarios. Okay, what can we do then if we can't talk about 100% coverage? It's better to think about, again, what is a useful amount. And again, that depends on the context, how important a certain function is and what the business risks are. But really, I have argued so many times about test coverage, I want to pull my hair out. So let's explain coverage with a metaphor. And as a metaphor, I'm using my favorite childhood game, Age of Empires 2. You start with a nice little town center and some villagers, and you also start with a cavalry, which I've now called the tester. So we go and explore and test, and some of the things we know what we will come across, like certain elements in the landscape, like rivers, and we know that there are wolves and boars on the map. And of course, we know that there are a couple of enemies on the map too, so you can write automated tests for that, let's say. So your tests run and everything is fine, everyone's happy. And then in the game, if you explore somewhere, the true black goes away. But if you leave the area again, there's a sort of fog that comes back. So this is also like what happens in testing and in automated testing, because the tests don't run 24/7 all the time. There are parts where they don't run. And even as a developer, you have to deal with this because you don't control all the code in your project. So the fog can also be seen as a metaphor for dependencies you have, like dependencies on other teams you're working with or libraries, etc. So then this happens. So let's say you had an automated test running here, and it tests if the wall of your village was still standing. And the test would be like, hey, okay, but yeah, you have race cars there, so what the fuck is going on? If you were exploratory testing, maybe you would have found those, but even exploratory testing doesn't give a guarantee that you've uncovered all the unknown territory. But yeah, you definitely want to find out if you wanted to find out this bug, right? In the game, this was an amazing cheat, by the way. These cars could like fire rockets and you could wreak havoc to all your enemies quite easily. But to me, coverage is more like a fishing net. You have to decide how wide and how deep you want to cast your net. But to me, it makes no sense to chase a 100% number. It's like chasing the Holy Grail, to be honest. But there are difficult choices to make. And there are certain contexts, and I've been there, where I had to argue with managers about why a certain code coverage number was just a false sense of security. Yeah, that's the reason I wanted to pull my hair out, because I didn't always succeed in convincing them. But risk still has to guide our thinking here. That is the purpose of testing. We want to uncover where the risks are, but also to us, it's sometimes hard to figure it out. Testing is hard, but we can use other models to at least communicate about coverage. Maybe you've heard of the agile testing quadrants. They're quite old by now and not really popular anymore, but I've used them successfully at work to at least get the conversation about coverage started. So when I'm testing in projects, I try to make sure that we do more than one type of testing, right? So I want to do functional testing. I want to make sure that as a team, we write the unit tests, the component tests, a couple of integration tests. Yes, of course. I make sure that we do a lot of exploratory testing as well, and we do usability testing often. But what if you're in a project and you look at these quadrants and you see, hey, we don't do performance testing or load testing or security testing? Well, that might be a problem. For example, my expertise is not at all in security testing, but at least I can see when we're not doing anything for it, and then give that piece of information to the PO, the product owner, and say like, hey, well, this might be a risk. Do you want to maybe get a pen tester on board to make sure that we don't have terrible security holes in our application? So to me, talking about coverage is communication. I'm trying to communicate about how well we're testing, what different types of testing we're using, and if generally as a team, we're feeling confident that our testing is good enough, right? I want to spot if we're missing something obvious, but I'm not chasing the Holy Grail. Another tactic that you can use is, of course, BDD and TDD. The beauty of this is also not chasing the 100% coverage Holy Grail, but it forces you to think differently about what you're doing. It puts risk at the forefront. And I think it's great if a developer already thinks about the tests, because it forces them to think about what can happen. So, big fan of this. But the 100%, it just gives you the illusion that you're done, that you've done everything if you've managed to reach this Holy Grail. And what if they believe you? What if management actually believes you and they're proud of you, like, oh, 100% coverage, woo! And then you go live and there's this terrible bug. And then what? How are you going to explain that? But you said you had 100% coverage. I don't know. I think you're putting yourself at risk here too. And just mathematically speaking, it cannot be reached. It's an illusion. What matters often in testing is the inputs and the outputs. And think about it. You have infinite inputs and outputs. So I wouldn't go for the Holy Grail chase, to be honest. Terror number 3. Testing equals quality assurance. This one drives me crazy because even a lot of testers are fine with calling themselves QA, quality assurance. I've never understood why. Because if we look at what quality is, the whole thing mystifies me, to be honest. What is quality? I mean, how can I, as a tester, decide if the user has a quality experience? Because to me, quality is like someone has to value the software that you're making. But I cannot ever decide for someone whether that is true, yes or no. So to me, quality is rather undefinable. And it's also largely invisible, because when I'm using software products, I want to have a smooth experience. I want to basically be able to get from A to B with as little friction as possible. But I don't go around using applications like, oh, this is a great quality experience. You barely know it if you have a quality experience. The less you notice the software you're working with, the less friction you experience, I guess the better your quality, but I don't know. The only thing I can say about quality is how you can ruin it. Because that is quite easy, actually. One person in the team can totally ruin it. If you have one developer who doesn't give a shit about code quality or doesn't give a shit about the end user, yeah, there goes your quality. So I do think it is important that it's a journey that you go on together as a team. But it doesn't make sense to me to make the tester sort of responsible for the quality. Like they can assure that you have quality. I cannot wave a magic wand just by me being present with the role tester and then you have quality. No, it doesn't work like that. It also matters if the team is supported well, if the company culture is good, if the company also really thinks quality is something to at least strive for, that it's something to nurture. So everyone matters if you want to reach quality, but I will never say like, oh, I'm quite sure we have a good quality. I'll leave that up to the user to decide. What I see happening in testing as well is that in order to make the discussion about quality at least a little bit easier is to like compartmentalize quality. We chop it up in these quality attributes, reliability, usability, functionality, etc., all the entities. But this is just a model of quality. Again, it's not reality. It does help to make the conversation more practical though. So that's what I would use it for, but I would never think that, okay, if I have all these quality attributes like good, then I have quality. I don't think that follows. I think you will get a long way with it, but you can never be sure. You can have a perfectly like technical, high quality, beautiful code, whatever, the developers are like super happy, but what if your users hate what you've built and they don't use it? Then it's not quality, right? Testing cannot guarantee anything, least of all quality. So that's why I hate the term quality assurance. Yes, I hate it because testing cannot be perfect. That's what I said at the beginning of the talk. Testing is open-ended. There is this large area of unknown and we try to uncover as much as we can, but we have the constraints in time. Time is the biggest constraint always. We're being put under pressure. It's the end of the sprint. Can you please finish the testing? Testing cannot be perfect. Reality isn't perfect. Reality is often messy. People have good intentions, they try their best, but testing cannot and should not try to catch all the bugs. We are not an insurance policy. We're also not there to do a ceremony. We're not there to just produce test cases and reports and other documents and then keep our mouths shut. We will try to find useful information, which can be bugs, but it can also be questions and skepticism about what is going on. But the aim of testing should never be to assure quality. To me, that's just arrogant and dumb. So if you want to call me QA, that's fine, that's up to you. But I see it as something like, okay, quality assistance, that I can make peace with. I'm more than happy to assist the team in their journey to create an awesome quality product. Or I'm a question asker, but I would never call myself quality assurance. I'm not that. Or just call it testing, nothing wrong with that. So those were the 3 testing terrors. But what if we want to transform them into testing wisdoms, and in a positive note? So then the first one, testing can be fully automated, would be testing is automation and exploration. Testing can have 100% coverage. No, test coverage is not a number, that's striving for the holy grail. But you do want to talk about test coverage, and you can use models to communicate about the effectiveness of your testing, to make sure that you use a lot of different testing types, testing techniques. And lastly, testing cannot assure quality, but it can assist in creating a good quality product. But in the end, it's the user who decides if they're having a quality experience. I also promised to give you some tips. So if you feel so inclined to learn more about exploratory testing, I can highly recommend the book Explore It. It's not even a really, it's not a big book. You can go through it quite quickly, and it will help you set up a systematic approach for your exploratory testing. And another book I really recommend from this list is The Perfect Software book by Jerry Weinberg. Basically, it's the same message as I'm trying to convey here, that testing isn't perfect, that testing has its limitations, that people would like testing to be perfect, but this book explains way better than I can why testing has its limitations. So yeah, highly recommend to read that. And Dear Evil Tester and Human versus Computers are more like funny books where you can read about ridiculous testing advice, and Human versus Computers is about really weird bugs that have popped up over the last few years. Really funny. And the Black Swan book I just like so much because, yeah, it forces you to confront yourself with that reality is messy and the world isn't Boolean outcomes. There's a lot of stuff you don't know and you will never know. So that is my message to you. Like, can you be comfortable with not knowing? Can you embrace uncertainty? Because that's what I try to do with testing. Try to uncover a lot of as much as I can, but I know it will never be perfect. I also have a couple of blog tips for you. You don't have to scramble to write down these URLs, because I have this URL here, and there you can download this presentation as PDF, so you can go over the book recommendations and blog post recommendations. And this also is the end of my talk. Hope you enjoyed, and I think, yeah, we'll have plenty of time to discuss in the breakout session. So, thank you.
Yeah. Wow. Again, an amazing talk. Thank you very much. Of course, I did a little bit about your background in testing, and as I mentioned also to you, I'm also heavily in testing. My question is, you mentioned quality assurance is not the right term. I always call it as an improvement engineer. Would you be able to fit yourself into that position?
Nah, to me it's just unnecessarily complicating things. I'm more than happy to I'm just a tester. Like, why all these fancy terms? Like, everyone is a unicorn manager these days. Like, why?
Yeah, I hear you. I hear you. We do have a question. Let's see, QA mode. That was the other one. Where is it? Yeah, are you familiar with mutation testing tools?
Sorry, come again?
Are you familiar with mutation testing?
Yes.
Okay, so Infection is a mutation testing tool for PHP. So
Okay.
it automates most of the mutations that can happen inside the code base, mostly oriented towards human error, but also logical errors and diversity of implementations. So most of the tests that happen in PHP are first and foremost unit tests, and then integration tests alongside with behavior tests. But since a couple of years, we're also applying mutation testing. But this is what we as developers do. Are there tools, techniques out there that can help us spend less time trying to reach that a magical 100% goal of code coverage, but more into what, as you explained, the exploratory approach? Are there tools, techniques, ways that we as developers can become better at it?
Yeah, of course, there are always ways. Problem is there are many ways and they're highly contextual. But what I think developers can do very well, because sometimes people think with exploratory testing that you're not allowed to use developer tools, but you are. So what I often do with exploratory testing is writing throwaway test automation, like code that is ugly as hell that you would never commit or anything, but just little scripts that can generate inputs, because I often find that inputs and outputs is where it's at, where the risk is at. So when I'm doing API testing in an exploratory manner, I write little scripts, then I have huge tons of data, it feeds it into the API, it does all the hard work for me, and then it spits out the result, and then I can analyze the result, but I don't have to manually do the API testing myself. That increases my coverage by a lot because it reduces the amount of time I have to spend doing the boring part of the testing, right? So yeah, for developers, I would say use all your scripting knowledge as much as you like, and you can write like small scripts that are ugly as hell but do the job. And then when you're done, you can toss it aside or just keep it for personal use, because it's about the information that you want to find. So that is one way to increase your coverage without chasing a number. But I do think that writing good unit tests is still very important. So I would start with that. But just, yeah, are you comfortable with writing unit tests without chasing some code coverage number to achieve? Sometimes you don't have a choice in the matter, which I've seen at a big bank in the Netherlands. There was this rule that they had to have 80% unit test coverage. And I kid you not, there was a police team that had to check if everyone was actually doing that, because what you get if you set this KPI is that people just write assert true is true to reach the number. And yeah, then what are you doing?
Yeah, those are yeah, boring tests, throwaway tests. They don't add value to improve anything. Yeah. I didn't even know that this was something that could be policed, but yeah. The world is full of surprises, and I still wonder why do I even am surprised by this. So okay, another question. Yeah, it's in the same trend. Multiple testing techniques to increase coverage. Yeah, you mentioned this, using your own scripts if necessary. Maybe this is a good one. What is the one thing developers can do to make the lives of testers easier?
One thing. I can name a couple of things, but one thing?
Okay, I think it would be good. Okay, if you mention a couple of things.
Yeah. Well, one thing is don't see us as the enemy. I've seen developers be incredibly defensive or scared of testers almost, but we're not the enemy. We care about making good quality software, as do you. So what I like to do with developers is pair testing. Like they made a feature and we sit together and we walk through the code and like, hey, I did this, hey, I did that. Yeah, because I mean, pair programming is also successful for a reason. Pair testing is successful for that same reason, because two pairs of eyes spot more than one. And I always appreciated it if the developer came to me and it's like, hey, do you want to test this together? And it's way more fun as well. But if there's just one thing, then I would say care. You have to care, because nothing is more frustrating as a tester than working with developers who just don't care. It's like they're just code monkeys. They're just typing in their computer, but they don't care. And I just don't understand. But those people do exist.
Yeah, I agree. I've seen them. I think that the majority of the people in the PHP community, they have a little bit more passion about the stuff. They're taking a lot of pride in their work, and also they do care about the results most of the time. So I hope that we have a better attitude towards caring for the program, the users, and the business. In the same line, we have a question from Mark. So the overlaps between testers and developers working together to help improve the product. So pair testing, pair sessions, having open discussion, not being afraid. Something you want to add to this list?
Well, the overlap is 100%, because if you're working in a nice team where people respect each other and like each other, then the overlap is 100%, because you have the same goal. You're just having different tasks to reach that goal.
Okay. And then here's another question. Okay, this is a tough one. Where would you start to implement a testing mindset in an organization where people are not used to write tests because of lack of knowledge and inheriting old legacy code?
Dude.
I would say hire me, because I give these workshops, but you also give workshops on this. So Maaike, feel free to present your details to Mark.
Well, I have a little bit of problem with this question. Maybe I'm weird, but to me, implementing a testing mindset, that is not exactly how it works. That's sort of putting the cart before the horse, and it's also extremely, extremely hard, because then you are really in the business of changing people, and it's an awful business to be in, really. So, yeah, it's almost impossible to answer this question without being a consultant right there and then, because it takes a long time, is very contextual. And honestly, yeah, I can't answer this question right now. It's beyond my pay grade. As of me being here, I can't help you.
Okay, well, I charge enough, so it definitely fits in my pay grade. So Mark, feel free to contact me after the session. Okay, I do see the paired testing in a TDD approach, where you write the test first, and then the dev tries to make the test go green together?
No, sadly, in my 10 years as a tester, I've worked at 0 companies that used TDD. I've only used BDD at times. So then it was like at refinements, we wrote the tests together as a team. But those tests weren't, obviously, they weren't unit tests, but more integration tests. So no, I've never done this in the last 10 years, only BDD.
Okay. Well, I have experience in this situation where I work closely together with the testers in the team. We were a mixed group of members. So we had a few developers, a few testers, some operation people in one single team. So this made the whole interaction a lot easier. Even though I am a fan of doing TDD myself, I learned a lot by working together with a professional tester in writing the TDD and challenging me to make the code go green after implementation of the code. So if you have the ability to do this, by all means, go for it. You only learn so much more about testing in the process. This is also a good one. Where to start? If you're faced with the situation where you have to write tests to cover top 10 untested business features and next month do the same again, or
I think it was a comment to the $1 million question.
oh yeah,
How to implement
I'm
testing.
doing it, so I don't see the conversation at this point. Okay. Well, these were all the questions I see in QA. Anything else? No, it looks like this is it for now. We're also doing a breakout session after the raffle. So if you're interested in learning more about testing and becoming
It's 9 o'clock.
Yeah, okay, thank you. Becoming more knowledgeable about testing, feel free to join us. It's an open session, so you can speak up and have conversations. So yeah, feel free to join us. Maaike, thank you very much for this session. Stick around. We're also going to have a raffle. And yeah, I was unfortunately not able to write all the names. So let me do this quickly. So give me 5 minutes and I will be up with the raffle. Maybe Paul can jump in and talk a little bit more about what's coming. Paul?
Yeah.
Okay, can you continue the presentation slides while I make sure that I have all the names in the raffle wheel?
Okay. Where are we? Of course, yes. You already all got the links in the chat, but it's very important that you leave your remarks about anything actually, especially of course about the speakers, but also how we can eventually also improve this meetup format. Are you now advancing this, Mike?
You have the buttons below, so this is, and then you have 12 of 16, and then you have arrow right. Next slide.
Yeah, sure, but
I'll probably misclick something. Sorry.
Yeah, I think some okay. Oh yeah, that's right. Almost forgot about it. So it's still the case. We will have an open discussion session with Maaike, but that will happen only after the raffle. What else can I say? Not much actually.
I'm at the B, so improvise.
Tell it. Raffle participants are probably based on Meetup. Well, I think it's rather the list here that we have. Oh yeah, kind of.
I'm at G, so I'm improving.
Okay.
I'm at M, but there are plenty of M's here.
Okay, then we'll have to be a bit patient.
Almost there. I'm at R. I'm at W. Yes, I have them. I have them. Okay. I think it's time for me to share my screen. Where's my button? Over here. Can I make this? Okay. Share screen. Are we seeing the screen? So I have put in all the names. So I think we can get started. As people remember, I'm very excited to give away free stuff. The first thing that we have to share is, and now I need to look at the list of things that we can share. Just a second. And yeah, wow, okay, I'm having way too many things open at this point. The first element to share is a PHP Benelux, sorry, a PHP elephant that is provided by Intracto, and let's see who's going to win. Everyone is still able to see. Let's start this. Press. Okay. Wim. I'm not sure what your last name is, but please stay in touch so we can have it. And we have 2 of those elephants to share. So let's spin the wheel again. Mark Walravens. Okay. And now we're going for 2 Heroku elephants. So the first one. Maaike, congratulations. And for the second one, Marcel T. And if I'm not mistaken, there was a notification here. Okay, so apparently we have Wim being our own Wim from the organization, so we need to spin the wheel again for the PHP elephant. Ivo, you get the elephant. And normally we also had vouchers for the tutorials of Spatie, but we didn't got them in time. So that is it for this month. If you're a company and you have things to give away, feel free to contact us. We love to ship it, and it's always nice to give away free prizes. So thank you all for coming, and let me go to the presentation a little bit. There you go. Oh, I need to end my sharing. So we had the raffle. Every second Thursday of the month, we have a meetup. So feel free to jump in whenever you have time. But for those who are interested in learning more about testing and having a nice discussion with a professional tester, with Maaike, stick around, because we're going to try something new, and we need some volunteers to help us make that possible. So thank you all, and we'll see you at the next event or in the breakout room. Maaike, I have no idea what I'm doing. That's why I'm a developer. So I'm going to figure out how to set up the breakout rooms. I wasn't able to set this up. Let me see. I have up to 25 attendees, so hopefully we can fill it, and hopefully we don't have an overspill. Otherwise, we need to have 2 breakout rooms. But let me just try it and see what happens. So I will put you first. Okay, I have now the open rooms, but I need to assign people to it. Are we in? Let me see if I can get like a feeling about how this looks like. Do we see? Oh, we have a main room. One unassigned attendee join the main room. And can we add people to the? No, I have no clue how it works. Just bear with me for a second. Okay. Da-da-da. Oh, I need to. For some reason, it didn't work. Let me try again, because 20 attendees per room. Okay. For good.
We are with less than 20 left, so I guess that we can add everybody to the breakout room and then send the invite. I lost
Yeah, it should have worked now.